This is part 3 for learning target 5. I can transform a quadratic from standard to vertex form, known as completing the square. And this is part 3, completing the square to transform standard to vertex form. So again, this is the second motivation for transforming from standard to vertex form for a quadratic function. So I just want to do a quick review of vertex form. So this is your vertex form. We know the vertex occurs at HK. So we're going to be able to find H and K from our standard form. We also know the axis of symmetry occurs at x equals h. And when we go between two forms, this a value is actually going to stay the same. So again, we're transforming, but again, we might be able to come up with a little shortcut to be able to go from standard to vertex form. So it takes 3 steps to be able to transform from standard to vertex form. So step 1 is that we have our quadratic function here. Step 1 is to subtract c and divide both sides of the equation by the a value. So remember, in standard form, that's my a, b, and c. And so I'm going to subtract the c from both sides. Right? And then divide by the a value on both sides. So the a value is 2, so I divide each of these by 2. And so I get a new equation, y minus 9 divided by 2 equals x squared minus 4x. The reason we want the a coefficient to be 1 so we can complete the square. So now we're going to complete the square like we were doing in part 1 of this video. So I want to force this to become a perfect square trinomial, so I need to add a value to it so that it becomes 1. Well, my middle term is -4 divided by 2 and square it, so that will be plus 4. But if I add 4 to this side, we have to remember to add 4 to the left-hand side. So now we have y minus 9 over 2 plus 4 equals, well, I need to factor that. So this factors to x minus 2 squared. The last step is solve for y. So y minus 9 over 2, I'm going to subtract 4 from both sides, equals x minus 2 squared minus 4. Multiply everything by 2. Y minus 9 equals 2 times x minus 2 squared minus 8. And my final step to solve for y is add 9 to both sides. And I get plus 1. And so my vertex form is y equals 2 times the quantity, x minus 2 squared plus 1. This means my vertex is at 2, 1. Now we could have figured that out also from the standard form if we review that the axis of symmetry is negative b over 2a, and so that would be 8 over 2 times 2, which is 4. And so notice, which is 2. So the x value of the vertex is 2, matches. And then if I plug 2 into my function, 2 times 2 squared is 8. 8 minus 8 times 2 is 8 minus 16, which is negative 8. Negative 8 plus 9 is 1. And again, we get the same vertex as if we were in standard form. Notice the a value in standard form is the same a value in vertex form. So let's try another example. If you think you're good, you can pause this video and attempt it on your own. This one will result with some fractions, so just be mindful of that. So step 1, subtract your a, subtract your c, and then divide by your a value. y minus 2 divided by negative 3 will leave me with x squared plus x. We're going to complete the square. So I'm going to cut the middle term in half and square it. So I need to add 1/4 to both sides. So y minus 2 over negative 3 plus 1/4 equals, factoring x squared plus x plus 1/4, since we know this is now a perfect square trinomial, is x plus 1/2 squared. Step 3, solve for y. Y minus 2 over negative 3 equals x plus 1/2 squared minus 1/4. Multiplying everything by negative 3. Adding 2 to both sides. So here, our vertex is at 1/2, 11/4. You can verify that if you want to find the axis of symmetry from the standard form, and then plugging in that value to find the y value of the vertex. But you should end up with the same results. Another example for you to try, pause the video, see if you get the same result. Subtract 2 from both sides and divide by the a value, which is 1, so we don't have to actually do anything. Divide the middle term in half and square it, and add that to both sides. So y minus 2 plus 81 over 4 is equal to x squared minus 9x plus 81 over 4. So this becomes y plus, this is the same as 8 over 4. So plus 73 over 4 equals x minus 9 over 2 squared. And so y equals x minus 9 over 2 quantity squared plus 73 over 4. And so the vertex of this problem is 9/2, 73 over 4. And so the last motivation for completing the squares, this is actually where the quadratic formula comes from. I would take some time to actually try to derive this on your own. It's just algebraically from the literal equation. And so I'm going to do it, try it, see if you can follow along. So if I'm going to solve ax squared plus bx plus c equals 0, I'm going to use completing the square method. And so I'm going to subtract c from both sides. And then I'm going to divide by a. So x squared plus b over ax equals negative c over a. Now our task is to complete the square on the left-hand side. So I divide b over a by 2 and square it. So to both sides, I'm going to add b squared over 4a squared. This is a perfect square trinomial, which will be b over 2a squared. And I'm going to find a common denominator, which is 4a squared, which will then leave me with b squared minus 4ac. So notice I have to multiply this side by 4a and that by 4a. And then I made it so that the b squared comes first. Now we can take the square root of both sides. Don't forget the plus or minus. B squared minus 4ac all over 2a, all over 4a squared. Now the square root of 4a squared is just 2a. And now subtracting b over 2a from both sides. Gives us negative b over 2a. Notice that's your axis of symmetry, plus or minus the square root of b squared minus 4ac all over 2a. And since they have the same denominator, we can say that x is equal to the opposite of b plus or minus the square root b squared minus 4ac all divided by 2a. So that's the third motivation for completing the square. You're able to derive the quadratic formula. And so that takes care of learning target 5.